Alright, so we started a series on Fourier and specifically Fourier series, and we're going to eventually develop from Fourier series, and we will go all the way from Fourier series to Fourier transforms, and we will look at their application and communication systems and things like that. So I think in my last video we got two different forms of Fourier series. So we started off with this form, and then we came up with a second form which is known as complex form, and we want to drive in terms of form which is in terms we're going to look at another type of a form. All right, so we're going to look at another type of a Fourier series form, and we're going to start off with form number one. All right, so here's the form that we started out with. We have a naught. You have summation that is going from 1 to infinity, an cos 2 pi n. N is number of harmonics, or you can say number of fundamental. You have fundamental frequency, second fundamental, third fundamental, fifth, sixth, and so on. Bn sine 2 pi n f0t. Now, the way we're going to come up with the third form, we're going to use the definition of cos. So we're going to use our Euler's identity. We're going to say cos of 2 pi n f0t. It is just like saying e to the j 2 pi n f0t plus e to the negative j 2 pi n f0t divided by 2. So we're going to use Euler's identity. So the first identity we're going to use, that's to show cos. Cos is e to the j theta plus e to the negative j minus j theta divided by 2. All right, so we had the argument that we had inside cos was actually 2 pi n f0t. That's why we just simply brought that argument with that e to the negative j. Same thing, sine, which is 2 pi n f0t. So as you can see why we're writing these identities, because I want to make these replacement over on this side. All right, so this is going to be e to the j 2 pi n f0t, all right, minus e to the negative e to the negative j 2 pi n f0t divided by j2. All right, so we're going to start off with these two identities, and we're going to start using these two identities, and we're going to place it in place of cos and sine terms. So this is how we're going to start. All right, so we're going to start off from here. So let's just bring this. So a naught, let's leave a naught as is. And what we're going to do, we're going to bring that summation sign in. That is going from n all the way up to infinity. Now, in place of cos, we're going to bring that a in. Of course, this is just a constant a in as is. And I'm going to bring that identity in. So this is going to be e to the negative j 2 pi n f0t plus a negative j 2 pi n f0t divided by 2. I hope you guys can see this. So a n is this. At cos, we're just plugging in the Euler's identity, which is this, and I'm going to do exactly the same thing. Bn, that is going to be Bn is going to be e to the j 2 pi n f0t minus e to the negative j 2 pi n f0t to j. I hope you guys can see this. All right, then I'm just going to basically simplify this. So I'm going to bring that a0 as is, and I'm going to bring this 1/2, which is common between this and this. There's a common thing which is 1/2, and I'm going to bring that 1/2 in. All right, I hope you guys can see this. So what I'm going to do, I'm going to bring this 1/2 out, which is common between this term and this term. All right, and once that, so here's a couple of steps that I'm missing. So I'm going to distribute an to individual one of these while taking out half common between these two terms. Same thing I'm going to do here. All right, same thing. So I'm going to end up with an minus jbn e to the j 2 pi n f0t plus half summation, right, I'm breaking them down individually. N is equals to 1 all the way up to infinity. An plus jbn e to the negative j 2 pi n f naught t. I hope you guys can see this. What have I done is this. Since summation is a linear operation, what I did, I took that half out, all right, and I combined them together. Or I can just rewrite it in terms of like this, where I have n is equals from n all the way up to infinity, or I can just have this whole thing inside of this while I have 1/2 and this term out. All right, I hope you guys can see this. All right, so once I do, okay, one more thing. You guys might be thinking, what happened to the sign? Why the sign has changed? The thing is this. So what have I done here is actually divide top and bottom by jj. So the j, that's why you have on top, you have jbn. Also at the same time, because j squared, I know that j squared is -1. So that has changed to -1. That's why we have a sign -1 when I take that sign up. So it will becoming that negative. All right. So after this, I hope you guys are seeing this. Now, the next thing I want to do, I want to change that summation. The summation that is going from n, that summation that is going from n is equals to 1 all the way up to infinity. I want to change that summation from this to negative infinity to positive infinity. This is what I want to do. I want to come up with a concise form. The third form of Fourier series is going to be a concise form. And I want to go, instead of me going from all the way up from 1 to positive infinity, I want to take all the signals that is from negative infinity all the way up to positive infinity. So what we're going to do, what we're going to do, we're going to take these individual terms. All right. So I'm going to say an is representing an component of my Fourier series in positive direction. Because we are changing summation, we want to go from negative infinity all the way up to positive infinity. So we want to look at an with respect to a minus n. All right. I hope you guys are seeing it. So a minus n, which is based on the definition, is just going to be 2 over t f of t cos 2 pi. All right, what is it that we want to change the summation to? We want to accumulate all of these sinusoids starting from negative infinity to positive infinity. So that is negative n f naught t dt. All right, I hope you guys are seeing it. Next step is we want to do same thing for bn. All right, bn, this is going to be 2 over t. That is going to be t f of t sine 2 pi negative n f0 naught t dt. All right. So if I were to look at this, okay, cos is an even function. So cos of negative x is just like saying cos of x, because cos is an even function. So this is actually exactly the same thing. It's just like saying 2 over t f of t cos 2 pi n f naught t dt. So this is just going to be, so a minus n is just same thing as an. I hope you're getting it. Why? Because cos of negative x is cos of x, because cos is an even function, while sine, that will change. Why? Because I have to bring that negative in, because sine is an odd function. And when you have an odd function, so I have to bring that negative out. So this would become 2 over t f of t sine 2 pi n f naught t dt. This is going to be your negative bn. All right. I hope you guys are seeing this. Okay, so now this is how our format is going to be now. This will change into this. So this top thing that we looked at, which was actually going from 1 to positive infinity, this thing has changed now. Now this new format of this is going to be a naught plus 1 half summation n goes from 1 to positive infinity. This thing remains unchanged. So this is going to be an minus jbn e to the j 2 pi n f0t, all right, plus half, which is this. Now this summation is going from n from negative infinity, negative 1 to negative infinity, and that is becoming an minus jbn. Why minus jbn? Remember, we had a positive sign and there's this negative sign, so negative bn. So negative bn, when I put this negative plus minus minus, so this would become negative jbn times e to the j 2 pi n f0t. All right, so I can rewrite this, I can summarize this right here. I can summarize this as this. So this would become this whole thing. So f of t, according to this third format, is going to be n as it goes from negative infinity to positive infinity, x of n e to the j omega 2 pi n f0t. This is what it summarized to. So this whole thing, the process that we went through, starting from format 1, we came up with this where I have changed my summation from negative infinity to positive infinity, and we have a concise format like this. So this is your third form. So what will be the value of your x naught? Because I need to calculate these x naught values. So x naught is just like a naught, which is nothing but a DC component. It's just like saying n is equals to 0, and your x of n is just nothing but an minus jbn divided by 2. So according to this, what is going to be your xn? Xn value is going to be an minus jbn divided by 2. In both of these terms, the thing that is common is what? Is actually 1 half. So once I change my limit from negative infinity to positive infinity, both of these things are common. So I'm just calling them an minus jbn, right, representing it 1 divided by 2. All right, so that's become your xn, and e to the negative j 2 pi n f naught 2, because f naught t, this is common in both of these terms, so that's why this is right here, and plus a naught. I'm sorry, so you can just put a naught here. So this is how it will become. All right, so one last thing I want to say about this particular format. So you will find that you can use this format, you can use any other format to actually calculate your Fourier series, which we will see in later in upcoming videos, that how do we actually do that. So we came up with our format, another form, third form of a Fourier series, which was n going from negative infinity to positive infinity. We have x of n e to the j omega 2 pi n f naught t, all right, where x naught is a naught, so n is just 0, and x of n, which I have already explained, an minus jbn divided by 2. All right, so how we are going to calculate x of n, x naught, and x of n. how to compute these quantities. All right. So the first thing I need to do when I'm computing these quantities is this. So these were some of the things that we have done. Okay. So I know x naught is just like saying x naught. X naught is just like saying a naught. So this is just going to be 1 over t f of t dt. It is that simple. This is just like x naught is just like a naught. So 1 over t integration with respect to the period f of t times dt. But what about xn? All right, xn is going to be 2 over t with respect to t. F of t, remember we started off with f of t cos 2 pi n f0t, right? I hope you remember this. This is actually coming from here, right? This is actually coming from here, this definition. 2 pi n f naught t minus j 2 over t. Why j? Because this is a sine term, f of t sine 2 pi n f0t dt, whole thing divided by 2. Right? So this is your an term, which is 2 over t integration with respect to period f of t times cos of 2 pi n f0t. Because cos is a symmetric function, that's why an and a minus n is just the same thing. While we have bn is 2 over t integration f of t sine 2 pi n f naught t dt, and j is coming from this, right? J is coming from here, and 2 is the division, which is dividing the whole thing. I hope you guys are seeing it. All right, so this whole thing, this whole equation, I hope you guys are seeing it. That's why we have a change in, that's why I have negative j is coming from this. Bn is actually 2 over t f of t sine 2 pi n f naught t dt. All right, divided by 2. Whole thing divided by 2. Now, when this whole thing is divided by 2, so I'll end up with, when this whole thing is divided by 2, just like I'm showing it here, these 2's will cancel out, so you will end up with 1 over t f of t, which is going to be cos 2 pi n f naught t minus j sine 2 pi n f naught t, whole thing dt. Can y'all see this? What have I done here? When this whole thing is divided by 2, because according to this definition, then these 2's will cancel out. So we took it out, 1 over t as a common factor, and then f of t as a common factor, and this has become cos 2 pi n f naught t minus j sine 2 pi n f naught t dt. Now if I were to look at it, this looks like an Euler's identity, and that Euler's identity is actually e to the plus minus jx is just like saying cos of x plus minus j sine of x. So if I were to look at it, this is exactly like an Euler's identity. So this would become 1 over t f of t e to the negative j 2 pi, since there is a minus sign, 2 pi n f naught t dt. Boom. This is how your equation would look like. This is your x of n. Okay, so this is how you calculate your x naught. This is how you calculate your x of n. in Fourier series third form. So I hope you like this small video on Fourier series, different forms of Fourier series, and this is the third form of Fourier series that you use to actually convert a signal from time domain to frequency domain. If you have any questions, leave it in the comment section, and don't forget to subscribe to my channel.